So in this video, we're going to be going through some examples of factorising quadratic expressions where the coefficient of x squared is not 1. So in the previous video, we showed the process of doing this, algebraic process, so hopefully we can now apply it in these scenarios. So for our first one, we've got 2x squared plus 11x plus 12. So the first thing to do is to multiply the coefficient of the x squared by the constant term, so the 2 by the 12. So 2 times 12 is 24. You're then looking for two numbers that multiply together to make the 24, but add together to make the 11, the coefficient of x. Okay, so 2 and 12 don't work in this case, do they? That's always a good one to check first, see if that works. So 24, 3 and 8. 3 eighths are 24. 3 times 8 is 24. 3 plus 8 is 11. So that all works out. Okay, so now I'm going to split up the 11x into 3x and 8x. Okay. Now, it doesn't matter, as I showed you in the previous video, it doesn't matter if we do the 8x and then the 3x. The next line will look different, depending on which one you chose, okay? But it doesn't matter about the process. The final result, you'll get the same thing. So, first of all, factorise this half, 2x squared plus 3x. Now, they both have a common factor of x, so I can factor that out. And I'd have 2x plus 3 inside the bracket. Now for the second half, 8x and 12, the highest common factor of 8 and 12 is 4. So I can factor the 4 out, and then I'd have 2x plus 3 in the bracket. Now because we've got the same bracket here and here, that means we know we're on the right track. So we have the 2x plus 3 as common factors here. And the other bracket is the x plus the 4. So we've now factorised our first one. 2x plus 3, x plus 4. Okay? So that's number one. Okay, number two. 2x squared plus 25x plus 50. First of all, multiply the 2 by the 50. So 2 times 50 is 100. So we're looking for two numbers that multiply together to make 100, but add together to make the coefficient of x, which is 25. So 50 and 2 doesn't cut it, does it? 25 and 4 doesn't cut it. 10 times 10, 20 times 5, that'll work. 20 and 5, 20 and 5. Okay, right. So now, split up the 25x into 20x plus 5x. And then we've got the plus 50 on the end. Again, doesn't matter if we do 5x plus 20x, same idea. Okay, now we're going to factorise our two halves. 2x squared and 20x. They both have a common factor of 2, and they both have a common factor of x. So 2x, and then we'll have x plus 10. Our second bracket, they both have a common factor of 5, and it'll be x plus 10. Same bracket, we know we're on the right path. So we're going to have the x plus 10 as one of the brackets, and the other bracket is 2x plus the 5. Okay, so 2x plus 5, x plus 10. Now I've just made a choice to put the 2x bracket at the front there. It doesn't really matter at all. It's just down to personal preference. So that's the second one. Right, the third one, 3x squared plus 4x plus 1. So first of all, multiply the 3 and the 1 together. So of course that's 3. So we're looking for two numbers that multiply together to make 3, but add together to make 4. And of course, 3 and 1 works here, right? So 3 and 1. So we're going to have the 3x squared. I'm going to split the 4x into 3x plus 1 lot of x. And then we've got the plus 1 on the end. Split it up into 2 pieces and factorise. So 3x squared and 3x both have a common factor of 3x. We'd have x plus 1 in the bracket. And here I've just got 1 lot of x plus 1. Same bracket, all good. And so we're going to have x plus 1 and then the 3x plus 1. So this is 3x plus 1, x plus 1. Okay. Now I anticipate maybe for that third one, and maybe for all of them, you're able to do it by just inspection. If you could do that, great. But it is always worthwhile having an algebraic method and knowing an algebraic method of how to do this. Number 4, we're going to do the 3 times 10 first. So 3 times 10 is 30. So we're looking for 2 numbers that multiply together to make 30, but add together to make 17. Well, 3 and 10 doesn't cut it. 15 and 2, that works, doesn't it? 15 times 2, 15 plus 2. So 3x squared plus 15x plus 2x plus 10. Split up into 2 halves, factorise each bit. So 3x squared plus 15x, they both have a common factor of 3x, and we'd have x plus 5 inside the bracket. The second part, common factor of 2, x plus 5 in the bracket, same bracket, all good. So we're going to have the x plus 5, and we've got the 3x plus 2. So 3x plus 2, x plus 5. Okay, and the last one. Now the thing with the last one is with 4x squared, 19x and 12, the 4x squared can either be done as 4x times x, or it could be 2x times 2x. And for those of you who want to try and do this by inspection, you've then got 2 possible options on the scenarios that you've got to work through and deal with. And as a trial and error, it's not particularly nice doing it that way. So let's do it our way. 4 times 12 first. 4 times 12 is 48. So we're looking for 2 numbers that multiply together to make 48, but add together to make 19. Okay, well 4 and 12 don't work, but it's very close. So what else goes into 48? 6 goes into 48, doesn't it? 6 goes into 48 8 times. But 6 and 8 don't quite work, so that's out. What else have we got? 4 and 12 don't work. 16 and 3. So that works. So 3 and 16. Right, okay. So then 4x squared, split the 19x up into 3x and 16x. Okay, so 4x squared and 3x, we can factor out the x. So 4x plus 3. 16x and 12, we can factor out 4. 4x plus 3. So we've got the same bracket. So 4x plus 3 and x plus 4. And we're done.